Before starting the class, I would request you all to just have a mindset like a child and then attend this class. Then you can easily understand this class, and also I am sure that you will have fun understanding these basic concepts. So coming to gravitation, gravitation is that which allows everything to pull everything else in a beautifully simple way, and this involves only two physical quantities, that is mass and distance. There is a law known as universal law of gravitation given by Newton. So commonly it is also known as Newton's law of gravitation. It says that there is a gravitational attraction between any two objects. Say if these objects are of masses m1 and m2, and if they are separated, if they are away by a distance of r, then the magnitude or the value of the gravitational force between those two objects is denoted by capital F and is directly proportional to the product of the mass of those two objects and inversely proportional to square of the distance between those two objects. Now this law is known as universal law of gravitation because it is applicable to everything in this universe, right from two point masses to celestial bodies like planets and satellites also. Okay, so this is known as universal law of gravitation. Now we say that if the force of attraction between these two masses is directly proportional to m1 into m2 upon r square, right? Now if I want to remove this proportionality symbol, I would apply a proportionality constant. This proportionality constant is known as capital G, the gravitational constant, and its value is 6.67 into 10 raised to minus 11. So please do remember this value along with units. This can be a MCQ question this time, because in the previous question papers they have not asked this question, so I am expecting this question this time. And this gravitational constant is, you can say that it is sort of a miracle actually. Because of this gravitational constant G, one could analyze everything related to gravity. This gravitational constant G was calculated first time by Henry Cavendish in 1798. This can be a GK question also. Okay. And G is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. This universal law of gravitation, we told that force is inversely proportional to square of the distance between it, right? So if I want to draw a graph on this, I draw it like this. I put gravitational force on y-axis and the distance between them 1 upon d square on x-axis. Then I get a curve like this. This curve is known as exponential curve. So they can ask a question, what is the curve plotted between gravitational force and the distance between the two objects is a dash. There will be four options. One could be linear curve, one could be exponential curve. So the answer is the exponential curve. And also based on this, many types of MCQs can be formed. They can ask any of one question in that. For example, if F is proportional to m1 into m2 upon r square, then if any one mass is doubled, then the force between those two masses will be doubled. If both masses will be doubled, then the force will become 4 times bigger. Okay, so this type of questions can be framed and asked. Or they can also ask a question like this. If the distance between two masses is doubled, what will happen? If the r, the denominator r, if it is doubled, then what will happen? The gravitational force or the gravitational attraction between them will be reduced to 2/4, or it becomes 1/4. Now because of this gravitational constant, one very important term called acceleration due to gravity was analyzed. You know what is acceleration, right? You are talking about the car moving on the road. Well, it is moving in a non-uniform velocity. You say that the car is getting accelerated. But then what about the acceleration of the object which is falling freely from top? If you are throwing a ball from your terrace, what about the acceleration of that ball? The acceleration of that ball which is falling freely due to gravitational force is known as acceleration due to gravity. Basically, the acceleration which is caused due to gravity is known as acceleration due to gravity. Its symbol is small g and its unit is same like that of the acceleration, that is meter per second square, and this also has magnitude and direction. That's why this is a vector quantity like our normal acceleration, and its standard value on the surface of the earth is 9.8 meter per second square. But in numericals where you don't require any accuracy, there you can use the value of g as 10 meter per second square. It will be easy for you to calculate and it will save your time. Now, what does Newton's law say? Newton's law says that force is equal to mass into acceleration, right? If that acceleration is acceleration due to gravity, then I say that force is equal to the product of mass and acceleration due to gravity, right? So I can write small g in place of acceleration a. It is very conveniently it can be written. So instead of saying force is equal to m into a, I can say force is equal to mass into g. Now, just now we have told that with the Newton's law of gravitation, force is equal to g into m1 m2 upon r square, right? See, remember this small g is acceleration due to gravity, capital G is gravitational constant. Please don't get confused, okay? The capital G is the gravitational constant and small g is the acceleration due to gravity. Now I have two equations, right? One is F is equal to mg and the other is F is equal to g into m1 into m2 upon r square. I can also write this g into m1 into m2 upon r square simply as g into capital M small m by r square, right? Now in left hand side I can write F as mg. Now this small m I can cancel so that I get the value of g, the acceleration due to gravity, is equal to g into capital M upon r square. If I am talking about earth, then small g is acceleration due to gravity of the earth, capital M is the mass of the earth and r is the radius of the earth.
You can use this formula if they ask you to find acceleration due to gravity. So this formula is important because any numerical can be asked based on this formula.
Now because F is equal to mg or F is equal to ma, in anywhere in kinetics wherein that motion in a straight line and all that, you can use F is equal to ma. In gravitation you use F is equal to mg. There was a 1 mark question asked in your previous year question paper. When g is equal to 10 meter per second square, the force of gravity acting on a mass of 1 kg is. Just apply F is equal to mg. You substitute. We have that they have given that mass is 1 kg. We know that the g is 10 meter per second square. Just apply it, and of course, what will be the unit of force? It should be Newton, right? Whether it is normal force or whether it is force of gravity, its unit will be Newton. So the answer will be 10 Newton. Now there are few more important points which you should know regarding this acceleration due to gravity. You know that Earth is not a perfect sphere, right? It is little bit very slightly elliptical. And also, as the radius of the Earth increases from the pole to the equator, the value of g becomes greater at the poles than at the equator. You should know this. This is 1 mark question. Why I will just tell you after some time, okay? Now this g, it is more or less constant near the earth. But if the object is far from the earth, then F becomes g into m upon r plus h whole square. In the denominator, in place of r square, you write r plus h whole square. This h is the distance between earth and that object, okay? Here they have their usual meanings, the terms. The F is the force between the two bodies. Here we are considering that the one body is the earth, for which we are mentioning capital M, the mass of the earth. G is gravitational constant, R is the radius of the earth, and H is the height at which the body is from the surface of the earth. Okay, just remember this. Now we assume that the earth is a solid sphere with a mean density. So density will be equal to mass upon volume. You know this, right? But then we know that volume of a sphere is 4 by 3 pi r cube, right? So I can write it as 4 by 3 pi r cube. And that's why I can write m is equal to, density symbol is rho. M is equal to rho into 4 by 3 pi r cube. But we also know that acceleration due to gravity is equal to g into m upon r square. So I can put the value of m here. So I get g upon r square into rho into 4 by 3 pi r cube. I can cancel r square with r cube. 1 r will be remaining. So my value of g will be 4 by 3 pi rho rg. So how is acceleration due to gravity g related to the density? Is this. This is the relation. Okay, you should know it. Now just a quick recap. Dimensional formula for gravity will be m0 L1 t raised to minus 2 because its unit is meter per second square, right? And then formula is gm upon r square. In SI system it is value is having 9.8 meter per second square, and in CJ system it is 980 centimeter per second square. So anything can be asked as a MCQ. So we cannot afford to skip things. Okay. Now we told that g is equal to 4 upon 3 pi rho rg, and then we also should know that acceleration due to gravity can be affected by certain parameters. What are they? Altitude above the earth's surface, depth below the earth's surface, shape of the earth, and rotational motion of the earth. But then what is the formula of g at height h and depth d? We have it. So how we derive it, you don't worry, they will not ask all this, but you should know the expressions because we need to relate the acceleration due to gravity at height h and at depth d. Okay. See, by this formula you can simply say that acceleration due to gravity at height h is directly proportional to the height, isn't it? Or acceleration due to gravity at depth d is directly proportional to the depth in the earth, isn't it? So they can ask a question like this. As we move from Earth's pole to equator, the acceleration due to gravity g, what happens to the acceleration due to gravity g? Now you can relate it. Earlier also I told you, right? See, if you see a globe, you can see that poles are at the corners and equator is at the middle. So what will be there in the middle? Height will be 0, right? In the middle of the earth, height will be 0. But at the pole, height will be maximum. And what we are telling, the acceleration due to gravity at height h is directly proportional to the height, right? As the height increases, the gravity also increases. So the value of gravity is greater at poles and it will be least on the equator. So the answer for this question is that as we move from Earth's pole to equator, the acceleration due to gravity decreases. Okay. Okay, moving on. We are talking about the planets, right? The planets are moving around the sun. Okay. Or moon is moving around the earth. We are telling that there is a force of attraction between the two celestial bodies because of which one is moving around the other. Okay. That is the gravitational force. Now Kepler gave 3 planetary laws. Okay. They are called the Kepler's laws of planetary motion. He described how earth is moving around the sun. First law he told is that the path of the planet is elliptical with sun at a focus. If you draw an ellipse, there are 2 points in ellipse called as foci. Okay. At one of the corner, at one of the focus, Kepler says that sun is there and around it earth is moving and its path is elliptical. It is not circular, it is elliptical. So this law is commonly known as law of orbit. And any type of MCQ can be asked based on these laws. For example, when a planet orbits the sun, one of the foci of the elliptical orbit is what? It is sun only. And the second question may be the Kepler's first law is known as law of orbits. So this type of questions they may ask. Then in second law he told that there is an imaginary line which joins the planet and the sun, and it sweeps out equal area of space in equal amounts of time. That means in one particular time the planet will have moved with that much area only, nearby sun or it is far away, because we are talking about ellipse, right? So whatever it is, in particular time, if you calculate the area, then the planet will have swept the same area in that particular time. So this is Kepler's second law. It is commonly known as law of area. So questions based on this could be like this. Kepler's second law is known as law of areas. Or they can also ask like this. Kepler's second law deals with speed, area the planet travels. Okay. Third law, Kepler told that the square of planet's orbital period, in certain time it is moving, right? The planet is moving around the sun. So if you do the square of that time, this is proportional to cube of the length of the semi-major axis of its orbit. Here I have drawn semi-major axis for you. This is known as the semi-major axis A. Okay. So according to Kepler's third law, the square of the orbital period is proportional to cube of the length of the semi-major axis. I have depicted very simple and easily understandable pictures for you all so that you can grab these Kepler's laws easily. Okay, so look at those pictures and then imagine what the law says. So this Kepler's third law is commonly known as law of period. Questions based on this could be like this. Kepler's third law is known as law of periods, or the formula of Kepler's third law is, here they have, for period they have given P, no problem. So P square is proportional to A cube. So I have made this lecture particularly based on your syllabus. I am sticking to the syllabus because we have very less time. We don't want to waste our time. So we will stick to the syllabus and prepare as much as possible. Then moving on. Now what is mass? You know it already, right? The amount of matter in an object is known as mass. The mass of an object, it is measure of its inertia. Now what is inertia? It is a property of body due to which it opposes or resists any change in its state of rest or uniform motion. For example, inertia means if you are standing in a bus, okay, then the bus driver suddenly he applies brake in the bus. Then your body tends to move front and come back, right? That is happening due to inertia. Your body doesn't want to change its state. It wants to keep on moving. But because the driver applied the brake on the bus, then it forced you to stop. Okay, that is known as inertia. So the mass of an object is the measure of its inertia. Greater the mass, greater is the inertia. And mass will remain same on Earth, Moon or outer space or anywhere. Mass is not at all going to change because it is depending on inertia. That's all. Now there is another term which looks like mass but it is not mass. We call it weight. Okay. For this we will have to deal in a different manner to understand it. Now we know that the earth attracts every object with certain force and this force depends on mass of the object and acceleration due to gravity. So much we have learnt. Now what is weight? Weight of an object is force with which it is attracted towards the earth. It looks like mass but it is not mass at all. It is a force. Okay, it is the force with which the body is attracted towards the earth. That is known as weight. Now we know from Newton's second law, F is equal to ma, or if we talk about acceleration due to gravity, F is equal to mg is there. Now force of attraction of the earth on an object is known as weight, I told you. Now because we are telling that force is equal to mass into acceleration due to gravity, in place of force I can write weight because weight is also force, right? So that weight is equal to mass into acceleration due to gravity. Now for example, if you have a question like this, mass of an object is 10 kg, what is its weight on the earth? Weight related to mass. Weight is equal to mass into acceleration due to gravity, right? And acceleration due to gravity, roughly it is 10. So m is equal to 10 kg is given. Acceleration due to gravity is also 10 meter per second square, you think. So 10 kg into 10 meter per second square will be 100 Newton. Okay. If you want to write accurately, then take g as 9.8 and then multiply it with 10, it will be 98 Newton. So this will be your answer. One more thing which you have to remember is that weight of the object on the moon is 1/6 times its weight on the earth. So if an object is on earth, say it is some 600 kg, then if that same object is on moon, then it will become 600 upon 6, it will become 100 kg. Okay. So a question may be asked based on this also. An object weighs 10 Newton when measured on the surface of the earth. What would it be its weight when measured on the surface of the moon? You know this is a trick. Then it is 1/6 times its weight on the earth. Then substitute the values 10/6 then the weight of the object on surface of the moon will be 1.67 Newton. Okay. Now just a quick recap and very important points these are. We told that the mass is a measure of inertia and weight, it is 0 at the center of the earth. And weight is force. It is related to mass as mass into gravity. This acceleration due to gravity, small g, is having unit of meter per second square. And it depends on height. Then gravitational constant we told. It is same in the entire universe. That's why it is come out from the universal law of gravitation. And one very important point is that the unit of weight will be Newton because it is force. Okay friends, this finishes your chapter gravitation. Please let me know if you have any doubts. You can write to me in the comment section or you can join the Telegram channel, and please share this with your friends as we have very less time. I am also working hard. I am working hard to finish the portion as soon as possible. I will be motivated if many of you watch this and get benefited. Okay. So please share with your friends and then subscribe to my channel and click the bell icon so that you get to know whenever I upload the videos. Okay.
Now I have gathered many multiple choice questions based on gravitation. Here I have not included Kepler's laws and all that. Just gravitation, because so much is given in your syllabus, right? So we will focus on gravitation and discuss few multiple choice questions. Not few, in fact I think there are more than 10 are there. We will discuss those multiple choice questions so that we will have more clarity on gravitation, what type of questions will be asked in Karnataka TET and all that. Okay. So the first question is, a body of mass 1 kg is attracted by the earth with a force which is equal to, 4 options are given. See, we know Newton's law of gravitation now. According to Newton's law of gravitation, we know that the force will be equal to 9.8 newtons. Okay. If mass is 1 kg means force will be 9.8 newtons. Don't even see the other options. Just tick the option which is having 9.8 newtons. Okay. Next question. The ball is thrown up. The value of g will be, small g means acceleration due to gravity, right? See, acceleration due to gravity, the concept of that or concept of gravitation, whatever it is, earth is pulling the objects towards it, right? In this question, they are telling that the ball is thrown up, means it is going in the opposite direction of gravity. So the value of g should be, yes, it should be negative. If the ball is coming towards earth, then the value of g will be positive. But the ball is going away from earth, means it is going in the opposite direction. So it will be negative. So option C will be the right answer. Okay. Next question. Which of the following statements is true of the value of acceleration due to gravity? They are given 4 statements. One statement is true about value of acceleration due to gravity itself. What are the options? The value is same on the equator and poles. Value is least on poles. Value is almost negligible on equator. Value increases from pole to equator. Now we know that the acceleration value due to gravity will be least or will be the smallest on the equator. So option C, the value is almost negligible on the equator, will be the right answer. Okay. Let's move on. Question number 4. The law of gravitation describes the gravitational force between. Now we know it very easily, right? Now after attending this class, all of you can answer this question. It will be any 2 bodies having mass. Any 2 bodies, if they have mass m1 and m2, then you will have gravitational force between them. Okay. So option A will be the right answer. Because the law of gravitation describes the gravitational force between any 2 bodies having mass. Next question. The Earth's atmosphere is held by the, of course, the Earth's atmosphere, it is held by the Earth's gravity, or else that atmosphere would have gone in the space. That atmosphere is around our Earth only because of Earth's gravity. That gravity is attracting that atmosphere. That's why it is staying around the Earth. So option D will be the right answer. Next question. Which of the following factors does the acceleration due to gravity on the earth depend upon? Now we know the formula easily, we can say this answer. It is that the acceleration due to gravity on the earth, it depends upon the mass of the earth. That's why option B will be the right answer. See, in our formula there is nothing other than mass, right? M1, M2, and we have the distance between the two bodies which is in the denominator. So you have to think about the mass. Then we are talking about the acceleration due to gravity on the earth, right? On the earth means it should be mass of the earth. Okay. Next question. Which of the following is true when a mango falls from a mango tree? If a mango is falling from a mango tree, which one of these given four statements is true? They are telling only the earth attracts the mango, only the mango attracts the earth, both mango and earth attract each other, both mango and earth repel each other. Of course, mango falls from the tree means both mango and earth will attract each other, but because the mass of the earth is very much heavier than mango, that's why mango will go towards the earth. Okay, so option C will be the right answer. Next question. Question number 8. The weight of an object on the moon's surface is. What is the weight of an object on the moon's surface? It will be 1/6 of the weight on the earth. We have solved that numerical, right? You know the answer now. So I will not explain it here. You will just remember this point that the weight of an object on moon's surface is 1/6 of the weight on earth. Okay. Next question. What is the value of acceleration due to gravity on the surface of the earth? We know it, right? It is the 9.8 meter per second square. I am giving this type of questions again and again because I want you all to be perfect with this value. Okay. Next question. What holds the Earth's atmosphere? See, same question, it can be asked in a twisted way. Either they can ask why is Earth's atmosphere around the Earth, or they can also ask what holds the Earth's atmosphere. It is the gravity. The gravity is the one which holds the Earth's atmosphere. Next, question number 11. The gravitational force between two bodies does not depend on. See friends, you have to read the question properly. Does not depend on their masses, their separation, the product of their masses, medium between the two bodies. According to our formula, F is proportional to M1 M2 upon R square. Means it is directly proportional to masses, inversely proportional to separation, directly proportional to product of their masses. Correct? What is the one which is remaining, which will not hold good here? That will be the medium between the two bodies. Whatever the medium is there, gravitational force will be present between those two bodies. Okay. Next, question number 12. The gravitational force causes tides, motion of moon, none of them, both A and B. See friends, this is a very important point. That's why I included this question here. Because of gravitational force only, we are having tides in the sea or the ocean or the beach. We can see tides, right? Tides means lehere. In Hindi they will say lehere. So they are tides. That is happening because of gravitational force only. And also the moon is rotating around the earth, right? That is our satellite. That is also because of gravitational force of the earth only. Okay. So option A and B both should be the correct answer. Both A and B. Next question. Newton's law of gravitation applies to. It applies to small bodies only, planets only, all bodies irrespective of their size for solar system. Now by this time we are clear that Newton's law of gravitation applies to all bodies, whatever their size will be there. Any two bodies having mass, you will have gravitation between them. Okay.